Okay guys, hello everyone, welcome back to your channel Harshita Academy. So in this session we're gonna discuss about motion a motion lesson. This is about video of class 9th physics, NCERT, CBSE and also foundation course. If you want foundation course and CBSE and NCERT topics, whole topics are covered in this chapter about motion lesson. So it is a physical quantity, we all know that, and in this chapter we're gonna introduce so many types of physical quantities. So this interesting chapter is very interesting. So let's get started our video. Firstly, we're gonna learn about what is motion. You all know that our channel name is Harshita Academy, which is the biggest academy where we gain lot of knowledge and concept understanding. So subscribe for Harshita Academy. So what is motion? Firstly, before going to this definition, we're gonna go for what is the actual meaning of motion. If in this picture you're gonna see here one tree, yeah, right? So these three, I can take this tree as a reference point. I can mark it with a star, you will see here. So this tree is a reference point. Nextly, here a red color car was seen here, you will see here red color car. This is this one. Okay, so I take this tree as a reference point, which is here 0 meters. I can draw a distance scale also 0 meters, and here up to 5 meters up to this reference point. Okay, not at all this reference point. Okay, 5 meters, I take it 5 meters. Means what is the distance of this road? I can take it 5 meters. So I can take this reference point. Firstly, this red car will be situated here in 0 meters and 0 meter per second. The time also 0 meter per second. So after 5 seconds, the car will be like this. Means the distance is changing according to time. Means the motion of an object, means the object's position will be changed. Firstly the car position is this. Now after some time, about 5 seconds, the car changes its position up to 5 meters. Means away from this tree. So the distance is changing, means the position is changing. What with a simple definition for motion? An object is said to be in motion if it changes its position with respect to time. With respect to its surroundings, a reference point over time. We calculate its motion taking by a reference point. Means changing its position with respect to time. It changes its position up to 0 meter to 5 meter for 5 seconds. For 5 seconds. So means it's take some time, yeah. Okay, at about 5 seconds it changes its position up to 5 meters. Means it changes its position respect to time. That's a simple definition for motion is change its position with respect to time. With respect to time. This is a simple definition. So let's an idea. Key idea. Motion is relative whether an object is moving on another dependence on the observer. So what is a relative word? Means we are comparing quantities. Here we can see that here I can draw another person here. Okay, if you can here 2 members are sitting here, one person 1 and person 2 in a train. So respect to one person, here 3 person. Okay, fine. Okay, here for one person, number 1 person means one person here named 1. This person 1 person. Okay, I take alphabets, it's not correct, yeah. Okay, oh my god, what happened? Yeah, okay, fine. So okay, take A person, B person and C person. So A person, respect to A person, be in position, rest or moving. Means a motion or rest. Okay, before that we're gonna discuss about rest also. What do you mean by rest? It's quite opposite to motion. Means if a person does not, or if an object does not change its position according to time or with respect to time, then it's called to be rest. Means the object or person does not change their position with respect to time. So here you can see here person A, person B, and person C. Okay, we consider these three persons as A, B, and C. So let it be A. Person A, respect to person A, the person B in which position means motion or rest? Yeah, of course rest, because a person A is sitting and person B is sitting besides. So here what we consider rest. So here rest. You're gonna see that its main point that it's a moving train. It's not a rest train, it's a moving train. Respect to C, person C. The person B in rest or means person C is outside the train, which is not situated in the train. He gonna see in the train tracks the train suddenly moving and see person B. So he think that person B is in motion. So respect to person A, he is in rest. Respect to person B is in motion. This is called a relative. It's an idea about relative. You're gonna see here key idea. Motion is relative, means respect to one observer, the object's state is vary, and respect to another observer, the state of that object will be vary. Example here, a person sitting on a train is at rest, relative on the train, but in motion relative on someone standing on the platform. It is about that only. Okay, let's go to describe a motion. The reference point. You're gonna study all those points here: types of motion, and distance and displacement, and uniform motion, non-uniform motion, speed and velocity. It's gonna be points all you already. Okay, guys. So here we're gonna go for describing the motion, the reference point. How to describe the motion? To describe a position of an object, we reference point called accelerated origin. We all know that respect to one origin only we can describe motion. So next definition: a fixed point or object from position of thumb of another object and described. You're gonna hit here a starting point. So reference point, position. Nextly example. The school is 2 kilometers north of the post office. Okay guys, it's all about relative only. We can also learn relative and reference point. The first example I also tell. So nextly we're gonna go for types of motion. It's very important, guys. We all know what is about motion. I think in your previous classes also you had learned about motion and types of motion. So revise them also. Motion can be broadly classified into different types. Mainly we're gonna discuss about translatory motion. Mean that firstly we're gonna look about these objects. They're all in motion. Yeah, this is a motion in straight line, and it's a periodic motion. I think yeah, it's circulatory motion, or else which is thing. So these three are the relative, and you're gonna see here rectilinear motion along a straight line. Examples also given that car on the straight road. Okay, you're gonna see here that it's an example for this rectilinear motion. Means the car which is moving in a straight line, means the motion which is done in a straight line, we call it as rectilinear motion. When we go for curvilinear motion, it's quite opposite to rectilinear motion. Means motion along a covered path, means curved surface. It's not a straight line. Yeah, rectilinear motion. We're gonna go for curvilinear motion. It's in a covered path. I mean it's not in a straight path. So rotatory motion about fixed axis, spinning top at rotation, means it's not rotatory, means it is a circular path. We simply say that the motion which is done in a circular path. So the very most important physical quantities are introduced here, that distance and displacement. We all know that what is meant by distance, which is the total length covered by an object is called distance. and scalar quantity has only magnitude always positive. About distance here, we tell about 2 points, which is shortly the total path covered by an object is called distance. Means if I not take this car, you wanna this ball here and this ball, it's only one ball which is move here. I gonna scale here, draw 0, 1, 2, 3, 4. It's a meter scale, 0 meter. You wanna imagine this is a distance scale is a 4 meter here. You wanna see here 0 meter, about 0 meter and 4 meter. Nextly, the small ball will go this in this direction, about here 5 meter and here 6 meter. Means the total length about here. The lastly the ball is here. How much distance it will carry here? Here 1 and 2 and here 4. Means 4 plus 2 5 6 meter. Total distance it carried is 6 meter. So this like you can calculate distance. And nextly we're gonna introduce a quantity called scalar quantity. What is the new name called here? Here this is very easy, guys. What is scalar quantity? Before that we're gonna go for what is magnitude. It is a number. If we're gonna talk about distance, 6 meter. This 6 is called magnitude, which is a physical quantity, means the physical number, which is a number, which is a quantity's number. We call it as magnitude. So here, let's see this magnitude, 6 meter. Then what is scalar quantity? It's very easy, guys, that. So about scalar quantity, magnitude, we all know that physical number which is present is called magnitude. Okay, scalar quantity means the physical quantity which is only considered about magnitude, which is only considered about this magnitude. So we call it as scalar quantity, which is not considered any direction. So means it's here the simple words is there. What happened to this? Okay, just a second. Okay, here we're gonna see here, yeah, has only magnitude always positive. And one thing is distance is very easy positive, because it's not means it's not negative, because it's not consider any direction. If it goes like this, it's minus points is there, no, but it doesn't consider any direction, so it always be positive. Whereas going to another physical quantity which is new to us, displacement. What do you mean by displacement? Just like a distance, but it's quite different. That shortest distance on a straight line path between an initial and a final position of the objects. If I take this as the initial, wait a little bit. Okay, this is initial point, this is final point. So what is the distance here? We know, I can take this is a home. It is a point of home, my home. This is a point of temple. I want to go, this is me, I want to go temple from my home. Then what I do, there is many ways. I want to go for like this and reach. I'm gonna go like this and reach. I'm gonna go like this and reach. But one thing left, that all these directions are gonna go straight line, which is the shortest distance. It's not rightly correct, yeah. What's the shortest distance? I'm gonna go like this, I'm gonna go like this, I'm gonna go like this, I'm gonna like this. What is the shortest distance is there? Yeah, it is the shortest distance. It is a, so let be a believe thing which says the displacement is the shortest distance between two initial and final position, which is the shortest path in a straight line. It's a simple thing we have to understand. So we're gonna confirmation about what is a displacement means. So let it be here. Next point, scalar quantity. It's a vector quantity because a displacement is a vector quantity. Scalar and vector. Vector means which consider has both magnitude and direction, means which is consider both magnitude and direction. And opposite thing is can be positive, negative, zero. What's this? Okay, zero. It can be it's not a printing mistake. And using this Harshit Academy is very useful for you because very advantages is there. New technique PowerPoint is created here, new animated videos and clear cut explanations. How useful using this free academy. So don't forget to subscribe. I will revise this point to you for your better future to understand the concepts in easier and funniest way. Okay, can be let's gonna be a topic can be positive, negative or zero. So here diagram also given that here point A and point B, which is the shortest distance. Here let be this is the shortest distance, blue color line. So this is displacement because the shortest displacement distance traveled in a straight line between initial and final positions. So here which is a core travel like this, which is called distance. This is distance and this is displacement. Nextly we're gonna go for new another two physical quantities called uniform motion, non-uniform motion. Here an object covers equal distances in equal interval of time along a straight line. Equal distances means if I'm gonna take 1 second, complete 1 meter. If I'm gonna 2 second, it complete 2 meter. 3 second, 3 meter. Means it's not correct here. Okay. I will take a clear slide here. Just wait for a few minutes. Oh, what is this? Okay. You want to take 1 second. Oh my god, how thickness is there? Okay. If I'm gonna take 1 second, 1 meter. It's a car readings, and 2 second, 2 meter. You can see here for 3 seconds, 3 meter. So by this about readings we can conclude that 1 second 1 meter means about 1 is carry here. So this equal, which is a uniformly it increases, means the uniformly its speed increases. Then we conclude that uniform motion, an object covers equal distances in equal interval of time. Here equal distance, you can see this here equal distances 1 1 1 and here equal interval of time. So the object covers equal distance in equal interval of time, then we call it as uniform motion. So we can call it as uniform motion. Next point we can here see this, here see wheel, speed is constant. Another point is speed is constant, means the speed is not changing. What we know about speed equals to, just a second, we know that speed equals to distance by time. So distance by time means 1 by 1. When we go for 2 by 2, 2 ones are 2 ones are. Is the here uniform motion means the speed is constant, about interval 1 1 1. The speed is also constant, it's right. For example, a car moving at a constant speed of 60 km/h in a state highway. The graph is also straight because for a uniform motion the distance time graph we will take here and distance here. The graph should be straight line. Whereas we go into non-uniform motion, an object covers unequal distance in equal interval of time. I'm gonna take another example here. Just a second. Here I will take. You will observe here. You will observe here that if we're gonna take for non-uniform motion, I can take 1 meter. For 1 meter, I will see here. For okay, here 1 second, 2 meter, and 3 second. Okay, 1 second. No, actually 2 second. Okay, for 2 second, it will be 5, not 7. So unequal increases 3 for it's going to be 9. means it's not a difference. We can check here difference for 2 5 and 7 to 9 2 means 5 to it's not equal, yeah, because unequal distances here, unequal distances are carried out for equal time. So what we conclude that unequal distances in equal interval of time. Speed is not constant. Yeah, of course here speed is not constant. Nextly, example, a car moving in a city, traffic speeding up, slowing down. Means in a traffic, a car is crowded in a traffic, which is speed is not constant. Yeah, okay. For this non-uniform motion, the graph also be covered, not in a straight line, not in a straight line. Keeping this in your mind, it's very important. For a non-uniform motion, the graph is only in a curved path. So let's go to our next topic. When we go for speed and velocity, another two physical quantities. So firstly, the rate of which objects covers means in simple language I can tell about that. In a particular amount of time, what's the distance covered? We call it as speed. Speed equals to distance by time, whereas velocity is speed with direction we call it as velocity. So here these two, which we consider these two are, here it is a scalar quantity, whereas it consider only magnitude, whereas velocity is vector quantity. It is scalar quantity, velocity is vector quantity. Formula: speed is equal to distance by time, whereas formula we can go for this velocity is displacement by time. Scalar quantity has only magnitude only. It's a vector quantity, and SI unit is meter per second and meter per second. Nextly, another two quantities we know, average speed and average velocity. Average speed means the total distance covered by total time taken is called average speed, whereas velocity, the rate of which changes its distance. Velocity equals to displacement by time. We all know that. Here speed and its velocity, it's considered direction. Nextly, another important physical quantity we're gonna go for is acceleration. Acceleration here, where acceleration, what is mean by acceleration actually? Acceleration means that a change in velocity by time. Acceleration means here we're gonna formula change in velocity by time. Means change in velocity means final position minus initial position by t. We call it as a. We can mention acceleration as small a. V is equals to final velocity, where u is equals to initial velocity, t is equals to time. It's a vector quantity, has both magnitude and direction. Acceleration. Now, nextly, acceleration equals to retardation or deacceleration, means negative acceleration. We call it as retardation or deacceleration. This is all about acceleration. And nextly, distance time graph and velocity time graph. What is the uses of graphs? It's a convenient method to represent an which is doing a thing. It's a convenient method. So uniform speed, straight line, upward slope. It's all about, there is two graphs mainly, distance time graph, velocity time graph, or displacement time graph. Where here distance time graph, where is a straight line here there. You're gonna observe here. Straight line means it's a uniform speed, which is uniform acceleration. It's a uniform acceleration, velocity. This is all about this lesson. The whole total lesson in a one shot we completed, guys. So for more like this interesting videos, subscribe to Harshita Academy. For more videos, subscribe to our Harshita Academy. Once again I say this, so don't forget to subscribe to our channel. Like, share this video to everyone. It's very useful. Subscribe to our channel Harshita Academy. Like, share our videos. Bye guys, see you in the next video with most interesting topic. And in our channel we had a idea to introduce some educational facts also. So to introduce that, you have to subscribe to our channel, which is very very interesting. So guys, bye guys, in the next video.